All right, today I got Travis Jones, fortified builder, somewhat of an expert in a lot of interesting fields. We're going to have a conversation about that today. Travis, you came in and you were explaining a little bit about pressure differentials.
Yeah.
And he brought in some interesting toys that we're going to show here in a second. But briefly describe what you do, and then we'll jump into that that fun little
Yeah, for sure. So
pressure test.
I've been in roofing the longest, and one of the things in this market you come to learn pretty quickly is, I like to say, the bar is pretty low for quality.
For quality, yeah.
And
absolutely.
a lot of corner cutting out there. So after a few years of roofing, I was always asking, how can I do it better? How can I do it better? And that's what led me to doing the fortified roof, and we'll get into that. I also got into solar. After the Snowmageddon event, I thought, oh, I saw another use for solar beyond just savings or being green. I thought, well, maybe if we lose power and you have solar and a battery, your house could be more resilient. As I got into solar, I found out it is an industry, unfortunately, that, well, a lot of people don't know what they're doing. They learn how to use a proposal tool, collect a utility bill, and then they just tell you to put as many solar panels on your house as they think they can sell you. So I was learning that business, and part of it is you're trying to find out how much energy does this house use. And I'm just a curious person. I'd say, wait a minute, this house, I looked at a house like this recently. Why is this annual usage so much higher than the one I just looked at? Why are we trying to put as many solar panels as possible instead of figuring out, can we make the house better, right? And I say that question, can we make the house better, is what led me down, I call the building science rabbit hole.
Okay.
So I started learning more about buildings and building science, and that's why I have all kinds of fun gadgets and try to help people. I mean, our mission at Smart Roof and Home Performance is basically making homes better using building science.
And when you say better, primarily it's efficiencies, right? You're going after efficiencies and comfort.
I love that you asked it that way, because I think when it comes to energy, when it comes to solar, a lot of the, stuff that the Department of Energy pushes, it's all about efficiency and saving money, which, hey, let's be as efficient as we can. There's nothing wrong with being more efficient. I like efficiency in life.
Yeah.
But I subscribe to the idea that efficiency is one of the pillars of home performance, and building science, but it's the side effect. The way you build better is by making homes more durable, comfortable, and healthy. If you do those things, what it takes to make houses more durable, comfortable, and healthy, the side effect is they'll be more energy efficient, if that makes sense.
Yeah. So a higher quality home always is going to be more efficient. And you talk about building science. I follow Matt Reisinger.
Yeah, Reisinger.
Yeah, down in Austin, and he's all about the most efficient ways to build it. And I say efficiency in the sake of the minimum amount of HVAC system you need to keep a house conditioned to the temperature that you want and humidified the way you want it.
Right.
And it's on the forefront of the build, which unfortunately you're on the back side of the build.
Yeah.
But when you're building a new home, you can different ways of framing, because a 2x4 wood is R1 per inch.
Right.
Yeah. So versus insulation, just 4 inches of insulation, get 13 or 16 R value.
Yeah.
In the same distance, you can get 4 out of a piece of wood.
Oh yeah.
So yeah, they're always talking about the corner should not be just a big block of wood. Let's make a cabinet.
You're sacrificing a lot of insulation value by framing that way. Sure, and I love all that stuff. I nerd out on it. I think someday I'd love to, fix our house up completely and then turn it into a good rental. And then I told my wife, I'd love to build you a house, the Matt Reisinger way.
Right.
But the truth is, we got to figure out how to fix the current housing.
Yes, you're working on a lot of houses. You're doing the fortified. Again, we'll jump into that in a second. But I'm curious about this pressure thing.
Yeah.
So when you came in, you're telling me you're dealing with a couple clients, pressure differentials in that when you have, because you've explained it to me before, really hot attic, not insulated properly, or there's more so than just the insulation, is the air pathways.
Yes.
right? So this you can put as much insulation as you want up there.
Right.
But last time we checked, chatted. You talked about the penetrations in the ceiling for can lights or any fixture that penetrates the ceiling.
Yeah.
Is now a pathway, right, for air to go back and forth, and it's going to follow the lower pressure. So let's see a little experiment real quick.
Yeah. So I'll pull my toy out in a second. I think there's, if you could understand one, it's really a principle of physics. One principle that has the biggest impact on our home's performance, and by performance I mean durable, comfortable, healthy, and efficient. The biggest thing that impacts, especially the comfort and health inside, is this idea that for air to move, all it needs is a difference of pressure and a path. If the pressure's different and there's a path, that air's going to move. So it could be the middle of summer. It could be today. I was in an attic that was super hot, but I'm not as worried about the heat in the attic. It's the humidity in the attic. It was also very humid. And so the other two principles, hot moves to cold and wet moves to dry. But how does it get there? Well,
it needs that pathway.
It needs a pathway. Heat doesn't necessarily, we could heat this surface long enough, we would get heat on the other side of the table.
Sure.
We could pour water on this all day long. It's not going to go through the glass.
Right.
So we can heat a surface, it can heat. But if there were holes in the table, if we had a difference of pressure and a path, we could get
a lot
heat,
of water.
We could get water. And then if you're talking about what's up in our attics, most attics I've been in, I know you've been in a lot of attics, that's not what I want to be breathing when I'm sleeping.
Yeah.
And so we have to solve that. How do we make sure that I call it, a lot of times when I'm making videos, I'm like, it's dirty, nasty, stinky air, because it is. How do we keep that out? Well, we have to air seal, because that pressure difference, that pathway is what allows that air to come in to our living space. So I will, here's one of my favorite little bags.
Bust out the toys.
Here's a thermal camera, which is great.
Yeah.
We talked about that a little bit last time too. This, fancy word for this is a manometer, but it measures pressure. We're going to turn it on. Now this, I got at the dollar store. And this, the technical word for this is, it's a balloon. So right now, this pressure, and it fluctuates because it's moving, but what it's measuring right now is the difference in pressure between this little input and the end of this tube. And the pressure difference is 0.
So the difference between, like if you were to put this somewhere,
right,
like you're outside a house and you just shove that in the attic.
Yeah, there could be a pressure difference, and this would tell us. And this is a very sensitive measurement.
So it's very two measurements at once, one here, one here.
Yeah, it's measuring this in reference to that.
And then you get your difference.
Yeah.
Okay.
So if we have this at 0, right? You hold that for me, okay?
That'll be on
all right.
camera there.
And right now, the question is there air in the balloon?
The small amount.
Yeah, but there's air. I mean,
yeah.
Is there a different pressure inside the balloon?
No, that'd be the same pressure.
Right? And so let's prove that. We can take our little probe here, and as we put it in there, let it settle. Yeah, there's no pressure difference.
Right, there's no pressure.
Okay. Now, once I'm good at this, inflate this. Okay, now that balloon is inflated because there's a pressure difference, right?
Okay.
The air pressure inside the balloon is pushing against it, the inside of the balloon, and we see the shape. But the air's not leaking.
Right.
The air's staying in there. It does not have a pathway out. And in fact, let's see how much
so if the
pressure.
air temperature was different in the balloon, it doesn't have a way out. It doesn't have a pathway.
And even if the pressure's, it's probably a little hotter because I blew it up and I've got hot air.
Full of hot air, yeah.
But if we could just get this in here, okay, look at the pressure. All of a sudden,
very high.
1,600 pascals. So when we're doing a blower door test, which we're going to talk about for reference, we want to depressurize a house to 50 pascals. This is a lot higher than that. But because there's no path, the high pressure stays in here. Mm-hmm. But as soon as we give it a path, the air moves.
Okay.
And now, back to this, there's no difference of pressure.
So if there's an attic that has a different pressure than the interior of a home, and we'll get to why it will have a different pressure in a second, but if it has a different pressure and it has a pathway like the penetrations we were talking about, and a penetration being cutting a hole in the ceiling, putting a light, a can, whatever, in the ceiling, now we've created a pathway that's not air sealed.
That's right.
And the pressure differential is going to push it into the environment that we're living in, that hot, nasty air that you were talking about.
That's right. That's going to come in any way it can. And this is where maybe we could talk a little bit about what the blower door does and how we use that to figure this out. So the blower door, and I don't know if we can link to it or people can look on my social media. I'm trying to show a lot of videos of it being in action because a lot of people don't know what it is.
Yeah, just send me a clip and
Confession.
We'll put it in.
I'd never heard of a blower door till 2 years ago. So, and I've been in construction. I'd never heard of it. I still talk to builders who don't know what a blower door is.
Most builders I know don't know what a blower door is.
Which is crazy because if we're building to code, we're supposed to blower door test a house to prove how airtight it is, and yet we don't know what blower doors are. So blower door is like it's the most important tool in kind of assessing the performance of a house because it starts by, let's measure how airtight the house is, okay? The more leaky it is, the opposite of that, the more we know that stuff from the attic, or if you have a crawl space, or even just around windows, doors, that air is coming into the house.
So we're sucking air out of the house. Mm-hmm. So a blower door is literally, we're covering the front door or a door in the home.
Right.
Everything is shut, as if you were living in the house, but one door has this plastic, like cellophane gasket glued to it.
Yeah.
And then a fan is pulling air and or pushing air, whichever you've decided for this test.
Right. Either one.
And ultimately, you would want to see what on a device like this. What's the goal? Because we're getting to the point where we are about to discover those pathways.
Right. So this is a single channel manometer measuring pressure. When you run the blower door, you use a 2-channel.
Okay.
And channel 1 has 2 of these inputs, one to reference the pressure outside. We actually run a hose outside, and then we are measuring the pressure inside compared to outside. And the goal is to depressurize, if we're doing that, to depressurize the house to minus 50 pascals, which is not a lot. You saw inside the balloon there was 1,600 pascals of pressure. So we're not trying to do something crazy, but we need to depressurize the house. On channel B, it is measuring the flow of air through the fan. And it's measuring it in CFM. And a lot of people are familiar with CFM. If you've shopped for bathroom exhaust fans, you're like, do you want a bath exhaust fan that's 50 CFM or 80 CFM or 110? Or if you've shopped for range hoods.
Right, CFM. Yeah, cubic feet per minute.
Cubic feet per minute. How much air, will that Viking range hood move? 1,200 CFM, whatever that number is. We're trying to measure how much air do we have to move to get to that, to maintain that negative 50 pascals of pressure. And the reason we're doing that, you can imagine, when I was a kid, we would get these 2-liter bottles of Coke and whatever a lot at parties. And when we're having a little junior high kid party, we're finished with the 2-liter, and maybe if you were feeling good that day, you chug it and try to show off, whatever.
Sure.
So you have that 2-liter bottle, and I think everyone can imagine this. You take that bottle, and you get your mouth on the end of it, and you suck in. And what happens to that 2-liter bottle?
Yeah.
It crushes. What crushes it?
A vacuum.
Pressure, negative pressure.
Yeah.
Right? Now, let's say we're going to make up, this is a really stupid game, but we could maybe sell this for Christmas. You take that same 2-liter bottle, and I say, okay, my lungs are stronger than your lungs. Let's see how many holes we can poke in this 2-liter and I still be able to crush it. Because the more holes you poke, the harder it's going to be.
Right.
Right? If you cut the end off of it, you couldn't crush it.
Right.
But you can imagine if you put a few pinholes in,
you could probably still crush it a little.
You could still crush it a little. And so that's the idea of your house, if your house were perfectly airtight, which nothing's perfectly airtight, and you ran a big enough depressurization, you could start to collapse the house, right? We don't want that, and so when houses, honestly, there are houses that are super airtight, they could use a very small fan. They could turn on their range hood, and maybe it's actually too intense,
much CFM,
too much. It moves too much air for their house, which is a whole thing they talk about. You know, people can search on that. High performance houses have to have what's called makeup air. They have to have something to let air in the house. The house is so tight.
Wow.
Now, we're not,
because you're pulling air faster than the little pinholes might be able to let the air back in.
Right, or the house is so tight you'll never be able to pull enough air for
Interesting.
it to get to that 1200 CFM.
Yeah.
You have to have makeup air, right?
Pretty sure my house is like a colander.
Yeah, so mine too. So, but here, back to the point. So we're blowing air out of the house at this negative pressure, and we look on there and we're like, okay, how many CFM? We plug all that into the formula, and it tells us basically, with that fan running, how many times in 1 hour would that fan suck all of the air out of my house and replace it with air from the attic, the crawl space?
Full air exchange.
Yes, air change, and so we use ACH, air changes per hour. A house built to code should only have 3 air changes per hour at that pressure.
Okay.
Okay, so it's meaning 3 times all of the air in the house is out.
At that pressure.
At that
which
pressure.
is completely unrealistic.
Right, it's anywhere from 10 to 15 times a normal condition.
Right. So we're not saying that houses circulate
No.
that many times
Right.
per hour.
No.
When depressurized, if there's a huge pressure differential, the house should.
Right, and that's why
cycle
I
3
call the
times.
blower. I like to think of the blower door as the amplifier, because it amplifies what's going on.
Yeah, you have a short amount of time to do this test. So
Yeah, well, and it'll show you things you wouldn't see normally. So when we've gotten to our sort of steady pressure and airflow, then what we do is we go around finding leaks. And I've got some videos showing this where you can put your hand up against, say, an outlet, and you can feel the air coming through the outlet in your wall. Where's that air coming from?
Yeah.
Well, it's coming, usually you have that outlet, and let's say you have your wire going all the way up to the top plate, and then they drill a hole in that.
Yeah, electricians drill a hole so
poke
they can
it
drop
through,
the wire. Yeah.
And now that wire's in the attic. But that hole where the wire just went, they didn't air seal that. So the air that's blowing through this outlet or light switch is actually coming down from the attic, and it's coming out.
That's the pathway you're talking
That's the pathway. The same with can lights. You cut a hole, pop it up there. If you do not air seal that, then air can come around that. I think we've talked about this before, but sometimes the condensation that we find on our air conditioning grills is from the fact that where that boot is in the attic, they didn't air seal around it. And so what is the reason it's dripping and sometimes even turning to mold is that the hot, humid air from the attic is being pulled around the grill. And as soon as it comes in contact with that cold metal,
Wild.
it condenses.
That's why you get the wet vents.
Yeah.
Interesting.
Yeah. It's the humidity from the attic being pulled in and condensing there. Again, that's just a pathway.
Yeah. Okay, so smart roof, home performance.
Yeah.
You're setting out one to seal these, right? Mm-hmm. So what would a homeowner, let's say I have you come in, you find 37 penetration issues where we've created a pathway.
Yeah.
What's the next step? And I mean, am I going to be out a huge amount of money? If you just find penetration, what's the normal course of action?
Yeah, so the reason I like all these tools and devices is they help me pinpoint where we're seeing the problems. So one way I do that is through pressure testing. So I have this big red box that I'll hook this up to, and I can take that box while the blower door's running. While it's running, I can take that box, put it over a can light, and I can see if it depressurizes, and I can tell how bad that is. Like if I took that box and just put it against the wall, it wouldn't change the pressure. But if I can put it over the can light, it's going to change it because of that airflow. So we're first kind of diagnosing what is it. I've been in some houses where the can lights weren't that bad. It was just maybe some of the other electrical, like the junction box that's on the attic side underneath the ceiling fan, or the smoke detector. It could be those. And so we're trying to use our tools and devices to pinpoint like what are the most egregious areas that need to be air sealed. We also use the thermal camera,
right?
Because if you think you can see cool stuff without a blower door running, once you're running the blower door, you see all kinds of stuff. And all the thermal camera, what it sees, it just sees temperature, surface temperature.
Thermal imaging.
Thermal imaging, right? Infrared. And so, you know, we have to always kind of remember what these things can do and what they can't do. So it's not seeing through walls, although it feels like it is.
It looks like it is.
Right? It looks like it's got X-ray vision.
But again, that goes right back to the fact that a 2x4 is R4 if we're lucky.
So it's seeing that temperature difference. Right. So we can see there's your hand really lighting up.
Yeah.
But even here, like you can tell that it's colder between the picture.
Yeah, so there are my fingerprints there where I was touching it.
Yeah, and I know.
So we can leave.
I watch my dog like run across the wood floor and you can see the paw prints, which is fun. So we're going and we're taking this and looking and seeing, okay, what's hot? I mean, man, with the glasses too, you look really cool. I'm gonna take a picture. So we use these devices and they're fun.
Yeah.
But they really do show us things. They show us where the leaks are, where we might have bad insulation, where we might have air leaks. So the solution oftentimes is to, if we can, and we're gonna do a job like this next week, we're gonna do a job where we're just air sealing because they have good insulation and there's good access. So we're gonna get a leaf blower and blow all the insulation to one side and air seal with spray foam.
Okay, cool.
We'll put little boxes on top of lights and spray foam those. We will, along the top plates, which we can talk about in a minute, why that's important, we'll spray foam. So we're gonna like trace the walls, if you will, with spray foam, cover the penetrations, then go to the other side, blow the insulation back over and do that side. And we're doing that, we can do that because they've got good insulation right now.
Let me ask you, what is it realistically?
Yeah.
Homes built 50s all the way through today. What can you come in and you find X amount of problems. What's an average, just say percentage change of energy use total and quality of life with the temperature differentials?
Yeah, I mean, it varies a lot, but I think we should be able to, well, first of all, going back to the efficiency and energy use, we use about 40% of our electricity or our utilities, gas. If you have gas appliances, that changes a little bit. Let's say 40% of it's used for heating and cooling.
Okay.
If we just air seal the ceiling and have proper insulation, you can improve that by your use by 40%. So it's not like you're going to cut your bill in half.
Right.
But you can, another way to say it is, we saw this CFM, right? We talked about CFM. So if you have there's plenty of range hoods that have a 400 CFM or so button. They might have like 3 speeds, but let's say it's 400 CFM. Every 400 CFM we can tighten a house by air sealing. And I'm verifying it because on my manometer that's next to my blower door, I'm seeing we're at 3,600 CFM, now we're down to 3,200 CFM. If I can drop it from 3,600 to 3,200, that's like saving 1 ton of air conditioning. So if you were gonna redesign the air conditioning for the house, you could say, oh, we thought it needed 5 tons, now it needs 4 tons. So that's what you're getting at in efficiency. By tightening it.
Say that again, because people know tonnage of
Yeah.
HVAC. You always hear air conditioning guys saying, "Oh, you need a 5-ton system for this house."
Yeah.
So say that again for the
Yeah,
uneducated.
So tonnage, a lot of HVAC contractors seem to just use a rule of thumb. They give you a ton of air conditioning for every 500 square feet of house or so.
2,000 square foot, you can have 4 tons.
4 tons.
So we'll do the math. I have a 4-ton unit for my 2,000 square foot house.
Yes.
You come in and you find 400 CFM worth of problems.
Yes.
You air seal it.
Yep.
You're theoretically saying I could go move down to a 3-ton unit,
Yeah.
which uses less power.
Yeah.
It's working less
Yeah.
just by air sealing.
Yeah. Now,
I mean, the savings,
yeah, it can be significant.
both energy and out of your pocket.
Yeah. Now here's the reality is, if we were really building well, you shouldn't have had a 4-ton unit to begin with in that 2,000 square foot house. You
fair.
probably needed a 2-ton. But the way we get you closer to that need is really by air. One of the most important ways is by air sealing.
Okay.
Now in a retro, I don't know, it's very hard to get to, the Matt Reisinger and the Build Show kind of standards.
Course. Yeah, it's difficult.
But the tighter we get, the more we can downsize air conditioning as opposed to oversizing. And the problem with oversized air conditioning is most homes don't have dedicated dehumidification. Mm-hmm. Which, like, in other words, a actual
Unit that
is just dehumidifying. What they have instead is they're relying on their air conditioner to dehumidify, which it does. It pulls moisture. That's why we have condensation lines that take all that condensation and they get rid of it into our sewer. But if we tighten the house, this is where it can get challenging. If you tighten the house and you say, "Oh, my air conditioner doesn't have to run as much," well, you're now actually not pulling out as much humidity.
Okay.
So sometimes, and this is, I think, a realistic expectation, I think most of the houses around here that I've seen, I feel like your first step is you would want to air seal and insulate. Live with that. See how your air conditioning system works. Knowing that when you redo, let's say it's time to redo your air conditioning. Now, if you had, like in my house, I have way more than I need. I have 7.5 tons for 2,500 square feet. And that was because the guy that I trusted was like, "Oh yeah, let's just bump I've got too much."
So now your system's cycling on, off, on, off.
Yes, and the more it cycles on and off, the more it uses electricity and the less it pulls out humidity. That's another problem. So
and the less time you have with that system.
Yeah.
It's on, off,
so what you want, we've done this for some people where we've tightened their houses, and then what made them the most comfortable, and you get an improvement by getting airtight, but then sometimes the HVAC guy has to come behind me and say, "Let's go ahead and install dehumidifiers." And that gives you the best result. If you can dehumidify, your dehumidifier does a better job of pulling water out of the air than your air conditioner does. Now, we want to let the air conditioner do what it will, as much as it will,
right,
but the dehumidifier does a better job, 3-to-1 in terms of efficiency. It'll pull out, for every 3 pints of water a dehumidifier will pull out of the air conditioner running at the same time would only have pulled out 1 pint. So they're much more efficient at pulling water out.
Right. For a very leaky house,
Yeah.
could you, would it be within the realm of possibilities to reduce their tonnage in half?
Well, it depends on their starting point.
Yeah, that's what I mean.
But yeah, it probably, if they're starting with kind of that rule of thumb, 500 square feet or 380, sometimes it's like 500, but if it's close, they'll just round up. You should be able to cut it. HVAC gets a lot more complex because now we also need to think about, is the ductwork good? Do they have the right design of ductwork? Do we have enough return and supply? And HVAC's a very complicated trade. The people doing it right they're doing manual J's and manual T's and manual S and manual D, and they're looking at it scientifically and saying, how much cooling does this house need based on all the right numbers. And honestly, one of the numbers that goes into that manual J to determine, the manual J basically tells you, do you need 5 tons or 3 tons?
Okay.
That's what a manual J will tell you. one of the inputs into the Manual J, in addition, it's like, bedrooms and windows. There's a lot of inputs into the Manual J, but one of them is how tight is the house? What's the ACH 50? So if you knew that, they're like, oh, we can step you down. This is how much cooling you need based on all those factors of the house, including how tight it is. So as you get tighter, you need less. So that's kind of on the energy efficiency side for sure, comfort side. I think the other thing that's huge is the health side, because it's the allergies and the asthma, and honestly, it's creating environments for mold when we don't have an airtight house. That's kind of what I'm most interested in. It's why I want to keep fixing and improving my own house, which is a really complicated house to fix, but it's because I want better air quality.
That's a good challenge for you, though. Good learning experience.
Oh, it for sure is. Yeah, and I do things. I'm making slow progress on it. But
for time's sake, let's move on to the other side of your business, which is the fortified roofing.
Sure.
And that's how I know you is through these different networks and chains, and it's the fortified roofing that you originally talked about. I don't know. I think I heard you speak maybe a year ago.
Yeah.
About fortified roofing, and briefly explain what the heck it is.
Sure.
And why there's only a handful of you guys in DFW, one of the largest metro areas.
Yeah.
Why is there only a handful of you?
Yeah. So fortified roofing, it uses better materials and better construction methods to give you a more resilient roof. That's the vision of fortified. The vision is not the better materials and construction. They want resilience. They want you to have a roof that's going to withstand hurricanes and tornadoes. And
how is it rated? How do we know that it will withstand?
Yeah, so what they do, so fortified is a program of what's called the IBHS, which is a nonprofit. It's like the Institute, Insurance Institute for Business and Home Safety, IBHS.org. They have some really cool footage on their website of their huge facility in South Carolina where they build houses, and they have this wall of fans, and they can generate hurricane winds, tornadoes. They can blast it with rain. They actually hit it with fire embers.
So they're actually building a house in what has got to be a gigantic wind tunnel.
Oh, it's not even it's like a warehouse with a wall of fans. I forget how many fans there are, but if you look at the picture, when you look it up, the fans are 6 feet in diameter. And then it's this giant wall. So and then there's great videos of them destroying houses. So what they do is they build it and they keep tweaking. So IBHS has this fortified standard. You can actually do a whole fortified gold, which is the whole house. And that's, from the ridge beam to the foundation, it's all tied together. And what fortified does is they tell you, use this kind of fastener, this spacing. Here's how we want you to do it.
And it's this Institute for Insurance, or Insurance Institute, whatever they are. Obviously, I mean, with that name, they're looking at premiums and potential losses.
They are funded by the insurance industry.
Okay, that makes sense.
The insurance industry, which includes all the names we know, the Allstate, Liberty Mutual, Farmer, all those, they fund them, but so do, and this is a whole nother conversation we can have later, but their insurance companies also have insurance. So Allstate has insurance, and they buy it from a reinsurance company. So it's insurance on the insurance. Well, they all fund this nonprofit, and to me, this is one of the rare cases where all the incentives align. The incentive for the insurance company, the incentive for the homeowner is, they said, figure out, let's just talk about the roof portion, figure out how we can make a better roof. For them, saves money.
Yeah.
But you know what? It saves money for the homeowner too. Because even if you pay more to get a fortified roof, if you can skip 1 or 2 or 3 cycles of having to file a claim, just saving your deductible, not having to, go through the hassle of a re-roof. Re-roofing's not fun. Nobody's like, oh, that sounds like a great day or 2 or 5, you can save. And then I think they're long-term, if more people get fortified roofs, in theory, we should have fewer claims. If we have fewer claims, our premiums should go down. We know they probably will never go down, but maybe they don't go up as much.
Right.
So fortified, it's the reason we don't see it in DFW very much is that it started in hurricane zones. That was their initial focus. So
East Coast, Florida.
yeah, North.
Gulf,
So they do thousands of fortified roofs a year in North Carolina, especially in the coastal areas, coastal Alabama, Mississippi. Louisiana last year started a grant program to give people money to do fortified roofs.
Interesting.
Because they were trying to get the insurance companies to come back to Louisiana. A lot of them had left. Too many losses, and that's what they say. Too many losses, we got to pull out. They're like, please come back. We'll help subsidize you, and we're going to do a fortified grant program. So the insurance, they're like, okay, that's less risk. We'll come back. The reason I got interested in fact, I think I learned about it from a Matt Reisinger video. He was doing a fortified roof in Austin, and I was like, oh, what is that? That's better. I want to learn about it.
Yeah.
And so I got certified last year to do it, and then we did the first roof a little over a year ago, the first fortified roof in Allen. We did one in Plano, Dallas, did one this year in Weatherford. So we're slowly trying to spread the word about what fortified is and when it comes to like how do people picture it, and of course they can go, Fortified has a great website that is educational to show people what it is. But I think there's 2 big ideas of what a fortified roof, why is it better than a regular roof? And it's 2 things. It's better attachment and a better seal. So let's start with attachment. When you're framing a house, you got your rafters, you put your decking on, and then I even saw one the other day. They stapled the decking on a house that's going to be a $3 million house. They stapled the decking. Fortified says we want, but most of the time there's a nail every, I don't know,
X amount of
8 inches, 12 inches. It's usually a smooth nail for some reason. Fortified says we want a ring shank nail that goes this deep, 2 3/8 nail, so that it goes this deep into the rafter every 4 inches.
Jeez.
Once you complete that, and so when we're doing a re-roof,
that's so many nails.
It's a lot of nails. When we're doing a re-roof, once we finish that part, we're re-nailing the deck. That doubles the strength.
Wow.
So that makes a difference. So that's like an example of better attachment. Better seal for them starts with sealing all of the seams. So by now we're used to seeing zip board on new construction and green boards and black tape. Everyone's seen that.
Yes.
So yes, water can get through the air, so let's tape it, especially wind-driven rain. But what about the same material that's this way?
Right.
Why wouldn't we tape those seams? So there's some really cool videos on IBHS site about this, but they tested it and said, in the event that your roof cover, your shingles and your felt, if it gets torn off and you still have a taped deck, then 95% of the water that gets in an untaped deck stays out. Only 5% of the water that would have gotten in gets in. So what does that mean? It means the difference between, in both cases, you need a new roof. But with the taped seams, you don't have to move out of your house while it gets fixed. You don't need a new living room.
Yeah.
You just need a new roof. Whereas where all the water got in, now you've got all kinds of damage and maybe mold remediation, all these things. And you think if the insurance company, in those 2 claims, they're saving a ton of money when there's a sealed roof deck. That's their incentive.
I was going to say, if the worst case scenario happens and your roof comes off, you're still waterproofed, and so the interior damage, because you got to think, okay, $30,000, the insurance is out for the roof, but if the storm is bad enough where it has ripped off the roof and it starts leaking in, you can quadruple that claim real quick,
real fast.
Wood floors, furniture,
mold remediation. I mean, just all the stuff that you have to go through, and then move out
Yeah.
And oftentimes, think about this, after a major storm event, you know what? How fast is construction?
Yeah.
Not fast. So if your house is not livable after that event, it's not a month. It's 3 months, 6 months, back and forth with the insurance. I mean, it could be a lot. So think of how much that saves the insurance company. And think of how much that saves the homeowner in terms of disruption to their life, in terms of their pocketbook. I mean, it just makes sense to do it.
It makes sense, but how much more does it cost? That's always the rub.
Yeah, I mean,
right.
So we keep trying to tweak that because it is more expensive. There's more expensive materials. We pay the crew more.
There's more material in general.
There's more material. But think about this. The grant programs that are out there are giving people $10,000 to upgrade to a fortified roof.
Okay.
So if the average roof's a 40 square roof, maybe that's $250 a square. We can do it for less than that. So, but that's because we have been learning how to do it better, how to do the right steps, how to train the crews. That's a big deal. Because the crews, unfortunately, in DFW, they don't even take all the felt paper off the roof, let alone re-nail a roof deck.
Right.
They never see roof decks because unfortunately, the majority of roofing crews are told not to tear down to the deck. So, I mean, fortified certainly swings way to the other side in terms of quality. But I'm thinking, and so what we do when we do a normal roof, the normal roof we do is better than, because we're using some of the edge details, and I won't get into all those details, but because I think the two big that you can picture is like, okay, putting a bunch of nails in and taping seams. There's also a way that you make the edges a lot tighter. It's funny, an inspector called out one of my edges because he didn't know the fortified standard. And so I had just done, it wasn't a fortified roof, but we did our edge detail, and you know that at the eave of the house, we have drip edge. That, where does the felt go? Above the drip edge or below the drip edge?
Trek says it goes above the drip edge.
Right, and normally it should.
Yeah.
But when we do a fortified edge detail, the felt goes under the drip edge because they want us to use a starter shingle that doesn't just have like a dash of roof cement, but is fully adhered, peel and stick. So our starter shingle, we peel the back of it off and it sticks to that drip edge. So water can't get...
Interesting.
So with the reason you want the felt here is if water ever gets under the roof cover, well, normally it's not sealed, so water could get under the drip edge.
Of course.
Right? But water's not going to get under. So it's funny, I did have an inspector call that out. He was doing like a pre-listing inspection for someone I'd done a roof for, and they're like, he said this is wrong. I was like, he hasn't seen it and he doesn't know, and I don't begrudge him for that.
I wouldn't know about it until I met you.
Yeah.
So yeah, we would definitely call that.
But we do that on every roof. We want to make every roof better. And if someone says I'm going to be here for a while, I'm like, consider doing fortified.
Yeah.
There are insurance discounts coming. A year ago there weren't, that I knew of in Texas. That's the other reason they're not doing it. We're not being motivated to do it. But Farmers is the first carrier I know of in Texas which will do a discount for fortified. And this is really cool. And this is not meant to be a commercial for Farmers. It's just they're the first people doing it. I hope they all start doing it. They will add to your policy, and it's not that expensive. Maybe it's a couple $100 a year. I'm sure it varies. But they call it like a better roof endorsement, meaning today, if I get a Farmers policy today and I add that better roof endorsement and I need a roof next year, they will pay to upgrade you to fortified.
Interesting.
Which is really cool. So I would do that hands down. I mean, people should do that. If you have the option, add it to your policy. I know, I suspect Nationwide will probably do it because they've always had like a better roof endorsement. Farmers is doing it. And then I think we're looking at, State Farm and USAA have been talking about bringing the discounts here. They have it in other places. It's just, it's not here yet in Texas.
Right.
So we do what's called the fortified, there's fortified hurricane and there's fortified high wind. Although I think they're going to just make it all hurricane at some point. But right now what we do is a fortified high wind, and then we add the hail supplement, which just means we're doing a class 4 shingle.
Yeah.
Like if you were going to do a fortified roof in Galveston, you wouldn't necessarily do a class 4 shingle. But you do everything else, all the other details. So you would just do a fortified hurricane, not a fortified with the hail supplement. You don't. If we need that in Galveston, we're in trouble.
Yeah. Things have changed.
But they do need that wind. I mean, it's crazy how much we can improve, whether it's on the ridges of the house or the edges of the house. We can greatly improve its ability to resist wind uplift, and all that. And it doesn't necessarily even mean like a totaled house situation. Sometimes the damage that a house sustains slowly over time. I was looking at a house earlier this week where the re-roof, they didn't extend the underlayment all the way on these little cornice returns, and the guy had a leak. And I went up to the shingles, and I was able to pick it up. I mean, I could have picked it up like this, and there was no underlayment, and the nail that was in the OSB board just pulled out, and it was rotted. Water was getting under there somehow, finding the path of least resistance, found a nail, and it had rotted it out. No underlayment. The edge wasn't sealed, which is a newer thing, but there wasn't even underlayment. I mean, we just get so many corners cut in the typical roof install. So that's where people have to educate themselves. You know, you can't look to, I don't think you can look to legislation. You can't look to building inspectors.
Right.
You got to, I am passionate about this, and that's why I really dedicate my Instagram mainly where I'm doing stuff.
I love your Instagram.
I want to educate people. Yeah. I want to give them the tools to make better decisions for their homes.
You're explaining it very well on there. Yeah, if you guys have not looked at his Instagram,
Travis builds it.
Travis builds it. It's worth a watch, and I mean, I learned quite a bit from it. I know most of it, but every once in a while you say something where I'm like, oh, interesting.
Well, you know, we got to be learning.
Yeah.
I mean, if what you do for a living, you're not excited about learning, then maybe you should do something else. This is not meant to be advice, but don't quit your job. But I mean, I love what I do. I love learning. I'm in mastermind groups. I connect with these other guys that are into higher performance builds. I want to keep getting better at what I do. What we do really affects, you know, even like on the inspection side, it matters for people's lives, because it's a sad statistic, but something like most people, the average person, spends 90% of their time indoors. Yeah. And now, especially with more work from home, a lot of that time is spent at home.
Yep.
The most time there is spent in your bedroom. I mean, how much of your life is spent in your house, an environment that may not be really good for you?
Right.
One of the most Googled phrases during the pandemic, because more people were at home, is my house making me sick?
Yeah.
And the answer is
sometimes.
Yeah, probably, it might be. Good chance. So
well, we do the air quality. We call it a home health evaluation. We're doing air quality, water quality, mold testing.
Yeah.
And when people feel sick, I don't want to say all the time, but every once in a while, we find some pretty serious problems in the house. We look at the numbers and go, there's a reason why you feel terrible all the time. You're coughing, you're always sick. And then a mold remediation company comes in there and they rip down a wall and you look at it and you're just like, oh my God.
It's crazy.
And so houses do make people sick. And if you're making the house, like you said, more comfortable, more efficient, built better, everything.
Yeah.
And that's something that Americans uniquely don't. Other cultures are different in that, but here we say, I got the X amount of money, build the biggest thing you can. Whereas other cultures might say, I have $200,000. Here's the minimum build quality I'm willing to accept.
Yeah.
How many square feet can I buy? And you might say, well, if you got $200,000 and you want this quality, it's not going to be a very big house. And that other culture might say, that's fine, but I want the best quality I can. Yeah. It's a difference of cultures. One, I personally, and you probably the same, I'd live in a smaller house that's built incredibly well.
Well, and then when we focus on our houses too, we're focused so much. What sells a house is the stuff that you can change.
Yeah.
Kitchens and bathrooms and countertops and showers.
You can't really change the framing or the structural.
It's very hard to go back after. Well, ductwork. Like, where should you, if you were building new and you said, here's our budget, here's the size we want, and they were like, look, we can build this for you, but to do really high performance and good ductwork and good air sealing and all that, you're going to have to sacrifice all these things. Sacrifice that. You're going to remodel your kitchen, but you're not going to redo it's very unlikely you're going to redo all your ductwork.
Right.
Do that right up front. Now to give people hope, because most people are like, well, you can kind of spin out and go, oh no, do I just have to build a new house? And we see plenty of issues in new builds. That's not the answer. The answer is educate yourself and learn as much as you can. Reach out to people. I interact with people on Instagram. I know lots of guys who like, oh yeah, and so there's plenty of free advice out there too.
Yeah.
And then when it's time to do something, prioritize. We really can go in, and I think we can make almost any house better. Not very few houses are sort of like beyond repair, beyond hope. We can make houses better, and we can do that oftentimes through air sealing and insulation, better roof, whenever it's time to do a project, start there. Let's do this right this time. Not cut corners, sacrifice the want-tos for these structural things. Again, durable. When you're doing a roof, that's the key to a durable house. Your roof's your umbrella. It keeps the water off your house. So do it right when you have the chance. When you're redoing a roof, especially in this market, everyone's going to probably get a chance to redo a roof. Make sure you do it right. But then on the air quality, all that stuff, don't fall for all the gimmicks and this machine that's going to do that and this, that, and the other. The best thing you can do is tighten up your house. And there's some DIYers that do it.
Yeah.
You can tighten it up, add insulation if you need it, and then get the right HVAC company that's going to really help you solve the rest of the puzzle, and you can have a really healthy environment.
Well, I appreciate you coming on today.
Yeah.
I mean, that was a boatload of information.
I know, it's a lot. It's a lot.
Next time we'll go into some other aspects, but I appreciate you coming on.
Yeah.
Guys,
Thanks for having me.
I'm going to put all his information down below. Fortified roofs, making your house more comfortable, making it better. You're the expert, so maybe you'll get some calls from this, but appreciate you coming on.
Yeah, thanks.
I'll see you next time.
Awesome.